Alright, draft physics video on the subject of the photoelectric effect, I think, hopefully. Generally speaking, maybe some electricity, generally speaking. Yes, so very draft. I just want to make a video for the message board and to have something on the subject. And I've just happened to be thinking about it, had some ideas, so I just thought we'd go over some of that. It's the whole Einstein thing with the quantizing of the photon based on the wavelength of light, and the idea of calling that an intensity of light, and the fact that you shine light on certain metals, and if it's ultraviolet light, it creates a current, and if it's infrared light, it doesn't. It provokes electrons to move, which is the tricky part here. Any of these diagrams goes back to the standard model and the standard understanding of how electrons and atoms are shaped and how they function, and I'm not overtly disputing what's believed, but I tend to disagree that it can be the way they claim it to be with all this action, so to speak. You know, electrons going very fast around nucleuses and all this kind of stuff. And all of these functions still have some sort of the geometric part of it, the math part of it, being that regular and consistent. And it's almost like the argument, if the atom was as big and as empty, well, not necessarily big, the atoms are small, but if it was as empty as they claim it to be, then it would be pretty hard to hit anything. You know, you'd have to go through an awful lot of atoms before you actually get to something you actually hit. And the idea is there really isn't a mechanism for saying you can bend forces inside of atoms and force them to hit something and all of that funneling and whatnot. So I don't think that the standard model in terms of the size of particles is appreciating their real size. The amount of space they occupy as part of the atom, I suppose is a better way to say it. But anyway, so the Einstein photoelectric effect discovered kind of lost meaning in terms of this difference between ultraviolet light and regular light, because eventually they found substances, like silicon, other things, where you didn't need to shine ultraviolet light to produce a current. You didn't need high intensity light. And I'm sort of arguing that the whole idea of converting frequency into intensity is a mistake, because it has nothing really to do with the amount of energy or potential to move something. It's just how fast the water goes into a bucket or something. It's not about how much water it is. And they're implying that ultraviolet light has more energy, when just all it has is more incidental ability to cause an effect, because timing matters. You know, often. How fast you do something, how slow, can change effectiveness depending on what it is you're doing. Like whether you're trying to tip something over or not, that kind of thing. So it really doesn't have anything to do with something actually having more energy. It's just there's more energy in an amount of time, but not over time. Maybe it's a better way to say it. Anyway, so I was thinking of what's happening between the electrons when a photon hits something that's capable of producing electricity. So a conductor of some kind. And so I was thinking of other different kinds of electricity and whatnot. So if these were the photons, the little round things I've drawn here, what I'm arguing, I only have the two colors, so I'm going to use another color, is that the electrons there's little bits of quanta between the electrons that are essentially the voltage, the pressure. So they're going back and forth, reflecting between. So if you add another one, it will create more reflections, so there'll be more pressure. And if you move the electrons closer together, you create more reflections, which is more pressure. So it's really the number of hits defines the amount of pressure or the voltage. And the neutral state of the conductor is essentially decided by what I would argue is its atomic structure, which we could just say is some shape. It doesn't really matter. And this electron is part of it. And the shape is conforming to some kind of pattern. And I would argue that what may be probable, like if we use a diamond shape, for example, you could see that these two wouldn't match up very well because the 2 points of the diamond, which might be electrons, are going to be close together, which means there'll be a high pressure, lots of rebounds, which means there'll be a tendency for these two things to push apart constantly. But if you stagger these, so if you stagger the triangles, you can see that that problem is mitigated in that the electrons can maintain distance from each other. So the proper way to draw this would be like this. So the same distance for the electrons can be maintained with without adding pressure. So there would be equal pressure throughout the system in a sense, because each thing would be consistent distance from each thing. So in a sense you can see this as being the electrons would have this kind of shape on the surface, based on the way the atoms would have to line up. And the other thing with a metal conductor is that it's kind of semi-rigid, in that you don't have a lot of capacity to mess with that shape except moving it in terms of domains. And I don't know if I want to get into domains, but there can be groups of them that are lined up, and then another group can have the shape that's compatible. So it's all compatible geometry. So even though it's not a perfect square, well, the diamond could be looked at as a square on edge. It's just that all the geometry would match, except the alignment is not the same. So if a group of these diamonds came out to be a square, and the diamonds were lined up one way, you could have a square next to them where the diamonds were lined up the exact opposite way. And what happens when something becomes magnetic is that they all line up the same way. All the squares have the same alignment. And then it becomes a polarizing filter. Alright, so anyway, back to the less than perfect drawing. But anyway, the idea would be is that what's happening in the electromagnetic effect, at least I'm arguing, is that something is, when my original drawing was less complicated than this, so I'm probably going to have to rethink it. But the idea would be, I'll just go with what my original thought was, and then we'll try to modify it maybe. The idea would be is that you don't have a perfectly straight alignment of the electrons, but you have an equal distance between them. So you have an equal amount of pressure between them, theoretically. And the idea would be is that if you visualize this as the electron and you say, okay, if I hit this with a little bit of force, it won't be enough to squeeze it to this location, because now the force here is going to be stronger and stronger, and so there's going to be a resistance to staying in that position, and it'll just pop back up to its normal position. But if you were capable of hitting it fast enough before it sprang back with another ton, so A single ton won't do it if it bounces back each time. So if it was infrared, you could sort of understand the first infrared, the first. All right, well, let's just do this real quick. So I'm arguing that the difference between infrared and ultraviolet light is the frequency, and the frequency really just represents the tons. It's the distance between them. So there's no real frequency. There's just a distance between the bits. And so in ultraviolet light, the bits come much faster. Okay, so that's the difference. So there's a beginning and an end to a photon. A photon is essentially something like bullets. There's a bullet, and then you fire another bullet, and that would be seen as a photon. If only one bullet came, you wouldn't see it as a photon because it doesn't have a frequency. So a photon technically is more than one ton as we see them, which does complicate this argument a little, because you say photon, you're really talking about one thing, but clearly for the purpose of the math or the quantization of a photon, you have to acknowledge that for it to have an impact, it has to be two. So anyway, so the infrared would keep coming in, and it's coming in at such a slow frequency that by the time the second ton gets there, so that the frequency is longer than this distance between the electrons, in the sense that the electron is able to bounce back before the second ton, the next ton hits. So it just keeps pushing it to this half location, and it doesn't get it anywhere else. And the argument I'm making is that the ultraviolet light hits, and it is able to push it, and then the second one hits before it's sprung all the way back. So it might spring back a little, the second one hits and gets it to a location, below the curve, let's say. A little bit below. So it can't spring back because now these forces are stopping it. So it can't just bounce back because there's more pressure on this electron saying don't go back here than there is pressure to go back. But it's not as much pressure was needed to push it into this location. So it's essentially, my drawing's a little bit off, but the idea is that it went a little bit below a flat line. And the point is now the distance between these electrons, this distance is much shorter than this distance. So the pressure has been increased by pushing the electron to this location, and that pressure is going to be felt by the other electrons getting pushed further away. They're going to try to even out the pressure. So that's one of the rules of conductors, is that whatever pressure or voltage you create, it's going to attempt to even it out because they're all connected. All the electrons are connected, and so any irregularity in the pressure is going to force them all to move to a new location to accommodate that unevenness in the pressure. Now, and because it's a conductor, it's rigid usually, part of that's going to be is that the pressure between them will have to be the same number of tons, because they couldn't maintain the same distance if there were greater numbers. Then the pressure wouldn't even out. So they'd probably have the same amount of pressure between them to start with. So anyway, so then you have the beginnings of this movement, because now this pressure has to spread over all these electrons. And the idea it would do that across the surface, because that's the straightest line from its perspective, and travel, say, around the conductor, and now it's going to have to push that atom back up, essentially going this way. This has to be, enough pressure has to be placed on this to push it past the neutral point, and it'll automatically pop back up to this point, and in that process perhaps release some infrared light heat. But the heat probably comes out in this process too of reorganizing the domains. And that's what creates the magnetic effect of the current. So it's a very tiny effect in such a small current that this would be. But the more current you have, the more these domains end up being, okay, so the domains were the shape argument. So when you have a few of these things stacked together, you can see you end up with a square if you if you draw them half decently. You could see that that would end up being a square, and obviously that square can be turned in all kinds of different orientations. And the argument would be is that the orientations tend to be forced to greater efficiency when they're feeling a pressure which now exists at this base from the electrons, which are saying basically we have too much pressure here, so that we're going to push pressure on the atoms themselves, and so it starts pushing on the atoms, and that makes the atoms squeeze, and so that means they have to get rid of any imperfections in their condition, which means they end up lining up, because that's the most efficient way to be. And the only thing that keeps them from staying in that efficient position is heat, the constant bombardment by radiant heat from the environment. That's why if you super cool something, it stays magnetic. It doesn't, and the current becomes highly efficient, is because it doesn't have to move the domains anymore. So you can run a lot more current through a conductor when you've gotten rid of all the radiant heat, because the radiant heat keeps turning these domains, keeps getting them out of alignment. So anyway, so the current tends to align the domains by creating more pressure, and then that eventually that pressure will be felt and push the electron back where it's supposed to be, I would think. Something like that. So that completes the cycle. But the idea that the only thing that's the idea that you maximize how much current you can put through the conductor by minimizing the amount of noise that you have to keep cleaning. So if there's nothing, less vibrations, less turning, then there's less you have to fix, and every push is more efficient in terms of the pressure moving from one end of the conductor to the other end of the conductor. There's less things in the way. Yeah, so I think that sort of explains that a little bit. The side subject that I was thinking about was just the way conductors can be turned into batteries, where you can store the electricity or maintain it, simply by turning them into capacitors, which is creating an incentive for the flow of the electricity not to go through the conductor, which is sort of interesting. So you can have two metal conductors, solid plates, and you can create this charge. Let's say you did just use photons, and you hit the surface with photons, and you're creating this extra pressure on the surface, and it goes and it migrates, and it would normally go right through back into the conductor and reestablish peace at the surface. But instead, because you have another conductor here, this other conductor reacts to the change in this face of the conductor as this pressure increases. And because this pressure increases, this pressure decreases, you could say. I mean, one plate goes negative, one plate goes positive. And this, so you realize say if this was just for the sake of understanding, this goes negative because it's got extra electrons, and then this goes positive, and then this goes negative, and this goes positive. So now you have a battery essentially between these 2 points. So you can keep piling the current on here and essentially store the charge, and increase the voltage, without it just draining constantly out of the conductor. But if you just had a plain conductor, you'd end up with a neutral charge because it would conduct through the metal. The current would keep going. So there's something about this creating this gap, and as long as the gap is narrow enough, you'll create a mechanism that appears to be a shorter line to the effect to get rid of the pressure. So essentially this becomes the easier path to get rid of the extra pressure between the electrons. So the need to fix the problem is neutralized here by creating a problem in the other conductor. So there's a problem here, and it's essentially transferred to here. And because of that transfer, it can just keep making problems and transferring them and creating a higher and higher problem of extra pressure between the electrons. So the point is that the voltage isn't the number of electrons, it's the pressure between the electrons. So it's how close the electrons are smashed together will increase the voltage, or increasing the number of these ping pong balls, or however you want to look at it, these little bouncing back and forth bits. So the more there are, the higher the voltage, or the more compressed, that means the more reactions, the more reflections, and the higher the voltage. So yeah, so I have to go through some more of this, but I just thought I would put this video up as an outline of how I'm thinking about it, and as I get it more solid, I'll make another video or add-ons to this video. The goal is eventually I want to be able to create a computer model, and so I sort of have to get some of this stuff nailed down before there's much point in trying to model it. The other side is if I start modeling, at least I can see it fail, and then I'll know what has to be fixed. But anyway, it's that's my goal is to get there eventually. Whether I'm going to get there eventually is another, who knows. But I just figured I want to get something on the subject posted, so that's the purpose of this video. I think that's enough for now, so thank you very much, and such.